Hello, welcome back to the One Human channel. We're here today to talk about solar power. This is part 2 of a series of videos that I'm doing on solar energy and renewable energy more generally. Let's get started. Hello, part 2 of solar power is solar energy and municipal self-sufficiency. In the previous part 1, we asked the question, can we produce all our power locally with solar? And the answer was yes. Actually, in Illinois, where I live, we could produce all the electricity we need with about 2.2% of agricultural land in our state. So the answer is yes. In part 2, the question is a little different. Could a county or city survive on its own solar energy production? That is, can we produce our energy locally for our needs using solar energy alone? So focusing on Galesburg, again, where I'm from, in Knox County, here's a little background. It was found, Galesburg was founded in 1837. The county was founded a little bit earlier, 1825. Current population of the city of Galesburg is 30,000, and the population of the county is 49,000. Those numbers will become relevant in a minute. The questions that more specifically we're asking are how much energy do we use in the city or the county, and how much land would be required to provide this energy? Because if we have sufficient land, then we have sufficient resources to do so. There's an important distinction to make from the get-go. In the previous video, and as I'm discussing it here, we focus a lot on electricity. A lot of people do. But electricity isn't the same thing as energy. It is a form of energy, but it's not the whole package. So what you see here in front of you was put together by Lawrence Livermore Labs. They put one of these energy flow charts together every year. This is from 2021. And you see at the top that 97.3 quads, and quads is just a very large amount of energy. But using that unit allows you to use numbers that you can fairly easily compare. So 97.3 quads is the amount of energy used in the United States in 2021. Now, the chart below shows on the left side all the different energy forms that are used, and those are in quads as well. So the top box is solar, that's 1.5 of that 97.3. And at the bottom is petroleum, and that's 35.1 of that 97.3. The other number I want to focus on in this chart, as it relates to this discussion today, is electricity generation. And so you can see from this flow chart which types of energy are used to generate electricity. And as the electricity generation box says, 36.6 quads of energy, raw energy, are used to generate, and as you see coming out of the right side, is 12.9 quads of electricity. So as we'll describe in the next slide and highlight, if you divide 12.9 by the 36.6, you actually can calculate an efficiency of that production. But looking at this chart, you can see 97.3 quads of energy are used, and in fact, in electricity, it would be 12.9. So key takeaways from the flow chart: electricity production accounts for 38% of all energy needs, and that's 36.6 divided by the 97.3. This gives you an idea of how much energy is required to produce electricity of the total. But because usable electricity is currently produced with about 35% efficiency, which is the 12.9 over 36.6 that I referenced, that's 35%, our electricity consumption is, if you look at it as a final number, is approximately about 13% of our total energy consumption. That's the 12.9 divided by the 97.3. So we can use that, that's a national number, but we can use that at state level to approximate how much energy is used in the state given a certain amount of electricity that we use. So we have pretty good numbers on the electricity use, and we can use that to extrapolate to find out how much energy we use total. Now, this number, 13%, seems like a very low number, and it probably surprises people. But what I want to emphasize, and I'll talk about it in later videos, that number, that 13%, goes way up if renewables are used. to produce our electricity. How much electricity does Galesburg or Knox County use? Well, in the previous presentation, we did a number of, in 2020, we used about 315 gigawatt hours. Well, we can extrapolate to the county. The county has 49,000 people rather than 30,000, and of course, therefore, the county is using about 515. And you can do that on a per capita basis to extrapolate to the larger numbers. That's how much electricity is used. Now, how much energy do we use? Well, given the number used in the last chart, we can extrapolate this number and say, well, if this is what electricity is, we can then know how much energy, or estimate the energy. And using the 13% estimate, you can see that Galesburg uses about 2,400 gigawatt hours of energy, and Knox County uses about 3,900 gigawatt hours. Now, those numbers, of course, include things like driving, right? Burning gasoline in cars, heating your homes with natural gas, right? Other uses of energy beyond electricity. Now, of course, we have electric cars, some, not very many, in Illinois, and we have, electric furnaces as well. So, and I'll get into that in a later lecture or discussion, presentation. We can produce this energy other ways. As of now, we're still using fossil fuels for most of that. So how much land is required to provide that level of need? And we use this in the part 1 video as well. This is the equation. Land area is equal to the total energy or electricity needed divided by these 3 terms that are multiplied. The full sun hours per day, the power rating of the panels, essentially the solar array, and then the time in year. And then you may say, well, it's a year. Well, you'll see. So those numbers from part 1 were 4.2 hours a day. That's full sun hours in Illinois. That's a good number to use. Power rating for a large solar plant was about 0.14 megawatts per acre, and then the time is in days. And we use days because when you multiply it all out, you get what you want, which is the land area, in this case in acres. So you can do the math. You can double check me if you like. For Galesburg, the electricity, for all electricity production, we could use 1,467 acres. And if we wanted to use solar power to produce all our energy, it would require about 11,290 acres. In Knox County, it's a larger entity, more people. It also includes the people in Galesburg. It is, for all electricity, require 2,400 acres, and for all energy, require about a little less than 19,000 acres. And then the question is, well, is this a lot of land, right? Most of us in the city folks, we don't think of things in acres. Again, an acre is about the size of a football field. So it looks like a lot of football fields, but let's compare it to, real areas. So let's look a little bit at our geography. This is Knox County, shown on the right. It's approximately 30.5 miles long and about 23.5 miles wide. And then the red square there is approximately the size of Galesburg. So that's how big Galesburg is relative to the county in which it resides. What are some real numbers, though? So the area of Galesburg, that red box, is about 18 square miles, and then you compute that into acres, you get 11,460. Knox County is 720 square miles, and about 95% of that is land, and we're going to just put panels on land at this point. That's 458,000 acres. Okay, so no, that's the size of the municipality or the county that we're dealing with. So to provide all the energy or electricity for Knox County or Galesburg, it would require what? Electricity, 13% of its land could be produced on Galesburg's, could produce all the power Galesburg needs, right? For electricity. 13% of Galesburg's land, of that 11,460 acres. If we wanted to produce all the energy we use in Galesburg, that is via solar power, we would use almost all of the land. So we'd have to cover essentially the whole city with solar panels to provide all the energy we use. And of course, we probably don't want to do that. But when we go to the county level, we look at electricity. We could produce all the electricity for all residents of Knox County, which would include those who live in Galesburg, with less than 1% of the land. And if you wanted to provide all the energy we use today, in Knox County, for Knox County residents, it would require about 4% of the land. So that's a much more reasonable number. It turns out it's about the size of Galesburg. So that shouldn't surprise anybody. So in theory, we would be able, if we covered the equivalency of Galesburg across the county with solar energy, we would provide all the energy we need. That would be all the heat energy, all the equivalent gasoline energy, which would be in the form of electricity in this case. Obviously, we would have to transform our systems. We'd have to change out gas furnaces for electric. We'd have to all have electric cars. This isn't going to happen overnight, but it's actually going to probably happen pretty soon. Sooner than you think. I'll talk about that later in future videos. So the closing thought is, the answer is yes. A county like Knox County in Illinois could provide more than enough land to produce all the energy it needs, about 4%. And when we do this calculation, I want to emphasize too that 4%, the assumption is that's going to go on agricultural land. It doesn't necessarily have to go on prime agricultural land. It could go on marginal land. It could go along highways. It could go on rooftops. So this idea that we would have to lose 4% of our agricultural land in order to do this, and that again is for all the energy we need in our county, for the residents of Galesburg, the largest city, and other smaller cities and towns, as well as everyone else in the rural areas. That's what we're talking about. We would need 4% of that land. So I think that's a pretty powerful indication. We also note, though, we would need the county to do that. The people in Galesburg could not do that alone, right? We would need to join hands with the county and participate in a larger project. Now, let's also want to emphasize, and I'll talk about this in future videos, we could do this and it would have other benefits, right? It would reduce our greenhouse gas emissions quite a bit. Probably if we did this, it would probably reduce our greenhouse emissions more than 90%. And it would also have huge economic savings and benefits, right? So it would produce money and it would also save us money. And I'll discuss those things later. Why are we discussing this? I could have started with this slide, but here are just two fairly recent, the last few weeks, headlines. Critical ocean current system is heading for collapse. Now, many of you may not study ocean currents and you may not think they're important. Well, life on Earth relies on them. Europe, for instance, is hospitable and actually livable for a lot of humans because of the Gulf Stream that makes it much warmer than it would otherwise be. This is talking about current systems, ocean current systems that are showing signs of radical change. That should really pique our interest. On the right, you see a recent overhead view of Illinois. You can kind of see the bottom of Illinois shown. This is from Lincoln, Illinois, which is the weather station for Galesburg. And you see we had very bad air, right? Very bad air. This wasn't just for a few hours. This actually occurred. There were two major episodes over the last month, and they both had significant impacts. And I think we don't really, we have to look at the long-term effects of these kinds of episodes. This is not something we want. And obviously one way to resolve it is to look at climate change in the face and try to do something about it. So that's it for the Bain presentation. I hope you enjoyed it. My book recommendation today is called Greentown, USA. This book is actually a decade old, but what it does is it chronicles a city in Kansas that had a major tornado in the early part of this century. And how did they respond to it? They could have just abandoned the city, or they could have, which was what they did, they turned it into a very sustainable city. And it's been a tremendous success, both economically and otherwise, and it might be a model for other cities. The question is, do we have to have a tornado destroy most of our downtown before we make these changes? And the hope would be no. So that's it for today. Have a great day and hope to see you for part 3, which will probably come out in about a week.